Welcome everybody to my channel. Today we have discussed the 5 problems. In between and them the problem 3, 4 and 5. 3, 4 and 5 are these 3 problems are on these 3 questions are posted on the Romania group, and here I shall solve the 3 questions. I am the solver, okay, of these 3 questions. Now this is now question number 1 is also an important question for these 5 questions are an important question for them, all of the very important question to the competitive exam, okay, like joint IIT and advance of this competitive exam, okay. Now see here the question number 1, 0 to 1, x minus 1 mod of, again this figure minus 1 minus x dx. We always follow in between the modulus, that is x minus 1 mod of that. If you any point like 0 to 1, like let us assume that is 0.9, if you put here we get negative. 0.9 minus 1 is we got negative. So we take the sign here minus, okay, and that is the transition. Okay, now again if we simplify within the mod, then you got here x plus 1 minus x and dx here, okay, and this is equal to 0 to 1, that is 1 minus twice x and dx here, okay. Now let 1 minus twice x equal to 0, then we get the solution half. So half lie on the 0 to 1. So split is integral from 0 to half, and that is 1 minus twice x dx. Again half to 1, and that is 1 minus twice x dx here, okay. And now again in between 0 to half. 0 to half means 0 to 0.5. If we take the any point in between, there is 0.9, 0.4. If we put here, we got positive. So we take the sign here positive, okay. 0 to half, and that is 1 minus twice x dx. Again from 0.5 to 9, 0.5 to 1. 0.5 to 1, any point take like 0.9. If we put here, we got negative sign, okay. So that's why the sign here is 1 minus twice x. And this is the easiest technique to solve this problem of modulus. And see, integrate this x minus x square, that is 0 to half, 0 to half, and again here is minus. So see, again x minus x square from half to 1 here, okay. Now calculate here 1 by 4. So now this is half minus 1 by 4 here, okay. Now if we put 0, 0, so again put 1, that is 1 minus 1, and minus 1 by 2 minus 1 by 4 here, okay. This is the solution of this problem, okay. This is a very good problem, that is half here, okay. So next problem, see the question number 2. Okay, question number 2. This is 2 here. Oh no, there is no limit. 2 into x to the power 12 and 5 into x to the power 9 by x to the power 5 plus x cube plus 1 whole cube and dx. In this problem, taken a common x to the power 5 from the denominator. So what happens here? 2 into x to the power 12, this is 12, and 5 into x to the power 9. Now x to the power 15 here, okay. And that is 1, x to the power, that is 2 here, and x to the power minus 5. That is whole cube. And divide by x to the power 15, this part, and also dx here. So this is 2 into, if you divide this, x to the power minus 3, and 5 into x to the power 9 minus 15, that is minus 6 and dx. Okay, and now 1 plus x square minus 2, this is whole cube. If we derivative this, we got, I think, yes, derivative of this part is this. Okay, so let's take, assume x is equal to 1 plus x to the minus 2 and x to the minus 5 here. So differentiate, dy is equal to minus 2x to the minus 3, minus 5x to the minus 6 and dx. Okay, and dy minus 2x to the power minus 3 plus 5x to the minus 6 dx. Okay, now this is equal to minus dy by y cube, and this is equal to minus y to the power minus 3 plus 1, and that is minus 2 here, half into 1 by y square and plus c. This is plus c, this is plus c here. So this is equal to 2 into y. Y means this is 1 plus x to the power minus 2 x to the power minus 5, and this is whole square. Okay, plus c. This is the answer. Okay. And now, first of all, we solve the question number 5. Question number 5. Okay. See my solution. Question number 5 here. This is x square plus 1 minus n square x by x to the 4 plus 1 minus n x square and dx. Now separate by this. Okay, x square plus 1 by x to the 4 plus 1 minus n x square dx, and again n square x by x to the 4 plus 1 minus n x square dx. Divide by x square, numerator denominator, then we can see that the 1 plus 1 by x square, that is the derivative of x plus x minus 1 by x. Okay, so divide by x square, then we get x square plus 1 by x square minus n here, and also let us take assume that is x square is equal to y. If we derivative this, then dy is equal to twice x dx. So you can take here 2 and balance by half here. Okay, now this is n square by 2 here, and 2x and dx, that is equal to y. And now see, this is the y square minus ny plus 1. Okay, and now again 1 plus 1 by x square and dx here. This is the derivative of x plus x minus 1 by x. So we can express this here like minus 1 by x whole square plus 2 minus n. Okay, and given that the value of n, that is lies between 0 to 2. 0 to 2 here. Okay, lies between 0 to 1. Means n is less than 2. N is less than 2 from 0. Okay, now I can see n square by 2, that is dn. We can express in the whole square pattern, that is 2y, and that is n by 2 whole square. This is more value are added, so we subtract by this from this relation, that is root over 2 minus n. Okay, this is whole square. So 2 minus n here is positive, as it is given the question, and value of n is less than 2 and more than 0 here. Okay, so that's why this is the formula 1 by a, that is root over 2 minus n, and tan inverse. This is tan inverse x minus 1 by x by root over 2 minus n here. Okay, minus n square by 2, and that's also formation to be written here, dy by y minus n by 2 whole square, and that is 4. Take LCM 4, and root over 4 minus n square in the whole square pattern. So again we write here root over 2 minus n into tan inverse 2x minus 1, sorry, this is here x square, and x into root over 2 minus n. Okay, minus n square by 2, that is 1 by a, this is 1 by a, this is root over 4 minus n square, and we have written here 2 here, so 2 are cancelled, okay. And now tan inverse, this is the tan inverse, this is value, that is twice by minus n, I have written here by, and 2 LCM are cancelled, n square, okay. And the value of y here is x square, so we substitute here x square by. Okay, this is the solution of this problem, and this is more interesting question for that. Okay, now do the question number 3. Now do the question number 3 here. Question number 3. See, has given that the sequence, that is an, it has a bounded real positive sequence, and now we assume a lower bound and upper bound, then you get solution limit n tends to infinity, that is summation k equal to 1 to n here, and 1 by n plus k plus n is equal to, we have to find the value. Now let's see here, the lower bound be small l and capital bound be L, upper bound be capital L, okay. So that's why for question number 3 you can write n plus k plus an, okay. From this sequence you can write here n plus k plus small l, where L is the lower bound, and of that upper bound be n plus k, of this value lower bound L, and of this upper bound is capital L, so n plus k and L, okay. And as it is saying that this is the reciprocal pattern, so that's why it is transferred to the reciprocal pattern like n plus k plus L, and this is less than or equal to more than. Now n plus k plus an, and this is equal to 1 by n plus k plus L, okay. And take a summation, and same as summation 1 plus k plus L here, and summation 1 by this is n plus k plus an, and this is also summation n plus k plus L here, okay. And this is summation from k equal to 1 to n, and k equal to 1 to n, and k is equal to 1 to n. This is my solution to the Romania group of this problem, and someone extra proposed this problem, proposed this question, and this is my solution. And see the technique here, and that is 1 by n, that is k is equal to 1. Let us take a limit here, okay, take a limit here, limit n tends to infinity, and that to be n here, so that is 1 plus k by n plus L by n, okay. And that's also more than that is L I m, n tends to infinity here, 1 by n, and summation k is equal to 1 to n, and that is 1 by 1 plus k by n, or n by n, okay. And again also limit n tends to infinity, so 1 by n here, and that is summation k equal to 1 to n, so that is here 1 plus k by n plus L by n here. Now these three parts, these and these here. Now we can write here limit n tends to infinity and L by n. This is equal to 0, and also limit n tends to infinity, and that is n by n is equal to 0. And again limit n tends to infinity, and means k L by small n. Sorry, this is n. This is n here. Why this is 0 here? N means this is a big number. that is tends to infinity. So 1 by n tends to 0 here. But L, A, N are capital L. This is the finite value. As n is a sequence and there it has a lower bound and upper bound is small n and capital L. So it has a bounded sequence, so small n and capital L are finite here. So it can be accessed like 0, 0 and 0 here. Okay. So now the question here is limit. This is the question. Limit summation k is equal to 1 to n here, 1 by n plus k and n here, and that will be written as like n tends to infinity, that is 1 by n, and summation k is equal to 1 to n and 1 by 1 plus k by n and n by n. Okay, and that is equal to limit n tends to infinity here, 1 by n, and that is summation k equal to 1 to n, and that is, this is a 0. Okay, that's why 1 plus k by n here. Okay, and now this can be written like that. Limit n tends to infinity. Okay, summation k is equal to 1 to n and 1 by 1 plus k by n here. Let x is equal to k by n, and this is the lower limit. If we put here 1, so as here k tends to 1, so x tends to 1 by n. So here n tends to infinity. So you can write here this is 0. So this is the lower limit to 0. If k tends to n, then x tends to n by n, and this is tends to 1. This is 1. So this is here 1 by n. Sorry, 1 by n means dx, and this is 1 plus x here. Okay, this is 1 by n here. Okay, that was missing. So that's why dx by this value to the base e 1 plus log x, 1 plus x, and 0 to 1, and that is equal to 2 here. Okay, this is the answer. Amazing problem. This is the most interesting problem to find the solution here. Okay, very good solution. And question is most interesting. And now question number 4. This also posted. This problem was also posted to the 1 year ago, and this is my solution here. See again for question number 4. Okay, this is a limit formation here. Now first of all we have to find the within the second bracket sum of this series, and then we got the answer here. So this is the term we have to find here, r term. As we why we find the r term, why not have any term? First of all, in the series, there the first term, second term are related with n, and the number of term are related with small n. So as well, first term are related with n, that shows that the n is there is constant. But in case of the if we find the nth term, so the n are the variable, n are the changeable, that is 1, 2, 3 like that. So these two are n are a problem to finding the sum of the nth term. So that's why we have to find the sum of the r term. Then after we put 1 to n. Okay. So now find the r term here of this series. So that is, we can take a 1, 3, 5, dot dot 2, dot dot 2, and this is a nth term, that is 2n minus 1, as it is a odd series. So you can let us assume a r term. So 2 are r. Okay. And now again, this is the first term here. So n comma n minus 1 comma dot dot 2. This is also a r term. So now the term here is 1 plus r minus 1 into d here. Okay. And this also a first term here is n, and this is r minus 1. That difference is minus 1 here. Okay. And now if we product this, that is 2r minus 1, and this is n minus r plus 1 here. Okay, multiply these two terms, then we got 2nr. Okay, minus 2r square plus 2r minus n plus r and minus 1. This is equal to 2rn minus 2r square, and this is 2r and this is here r. Okay, ठीक, right, 3r minus n and minus 1. Now we have find the sum. This is n notation, means I have to find the sum 1 to n here. Okay, so that's why the symbol here r is equal to 1 to n, so that is tr. So you can take the variable here is r, but n here is constant. So that was the problem to find in the sum of the series for. Okay, now this is r equal to 1 to n, that is r here. So 2 r equal to 1 to n, this is r square here, 2r square to n, 2r square, that is 3. So this is r equal to 1 to n here, r, and this is n here is constant, so r is a variable. So r equal to 1 to n to 1. So this also r equal to 1 to n, and this is a 1. So now see, this is 2n and sum of 1 to n, so that is equal to n into n plus 1 by 2. So 2n into n plus 1, and this is 2n plus 1 by 6. So 3 into n into n plus 1 by 2. This is n into n, and this is also n. Okay, this is a short simplification, n square, n plus 1. This is 1/3 here, so n plus 1, 2n plus 1, and this is 3 by 2, n plus 1 minus n square minus n. Okay, this is Sn. So now find the limit here, n tends to infinity, 1 dot n plus 3 dot n minus 1 and dot dot, and that is equal to sine 1 by n cube here, and that is equal to limit n tends to infinity. So sine 1 by n cube, and put the n plus 1, 1/3, n into n plus 1, 2 into n plus 1, 3 by 2 n into n plus 1 minus n square minus n. So this is equal to limit n tends to infinity here. We take a common n cube. So this is n cube here. So divided by n cube, that is 1 plus 1 by n. Okay, n cube, that is 1/3, 1 plus 1 by n, that is 2 plus 1 by n here. So 3 by 2, 1 by n plus 1 by n square. So this also 1 by n and 1 by n square. Okay. Now see here, this is equal to, I can written here, limit n tends to infinity. So n cube and sine of 1 by n cube here. Let 1 by n as a y, so y tends to 0. So limit here, y tends to 0. This is sine y cube by y cube here, and that is equal to 1. So this that's why this is a 1. So now 1 plus 0 minus 1/3. This is 1 plus 0. This is 2 plus 0 here. This is 0 plus minus 0 minus 0. Okay, and this is equal to 1 minus 1/3 here. Okay, oh sorry, this is 2/3. Okay, and this is 1/3. I think this is the most amazing problem for this video. There are the 5 solutions. So bye. See the correct list. Okay, bye.